Okay, hey everybody, thank you for joining. And we're going to talk about some of Korsivsky's ideas, time binding, and uh, and how that could be relevant to the development of AGI. So a lot of people have been asking lately. That's actually one of the questions that Ben was asking people to think about at AGI 22 was, what do you think the next step is? And that's kind of one of the things I really want to discuss with you. So I want to make sure right now everything, Mike, it looks okay. You can see the slides and all that.
Yeah, everything looks good.
Okay. So let me see if I can. This is okay. Okay, so a little bit of motivation. I don't think that many of us would disagree that there's a strong need for AI that does some basic things that humanity desperately needs, from self-driving cars. One thing that was very interesting to see, I don't know if you've had a chance to see Elon Musk's interview like about a month ago. I'll have a link in the slides, which we'll share later, where they were asking him, so what, you've been promising autonomous, vehicles all this time, what's happening? And he said, well, he thought initially that it was like a computer vision problem and, existing sort of control and sort of software engineering would do it. And he said, but he's beginning to realize that you need, quote unquote, real AI, right? And I think that's what we're really talking about when we talk about some of these AGI things. Another motivation is it's so inefficient the way that we're currently training these enormous large language models, using hundreds and millions of watts, to train models. And then, when the algorithm changes or, we have more data, you have to do it again. So we're definitely, I think we're in need of something that is more efficient, that works better, generalizes better. Obviously, all sorts of applications. So I'm not going to spend a ton of time on the motivation piece. I think we're probably all on the same page that we're all highly motivated. So as I go through this, it would be really useful if you stop me, ask questions. If something's not making sense, it should all be pretty basic. One interesting thing, I just was at a big business conference, Gartner Data and Analytics in Florida, and even the big business is realizing that the future is hybrid, right? So it's not, I used to call it neurosymbolic, but there's, as I was just talking with Boris, it's pretty clear that it may not be neuro, and besides, what we call neuro is not anything like what actual neurons do. It's a really very toys, but hybrid is clear. You're going to have different learning algorithms. You're going to have symbolic representations. You're going to have sub-symbolic representations, knowledge models, and so it's kind of a lot of different approaches that have to get mixed in there. Some people call it neurosymbolic. Again, I think hybrid is good. Another approach, because hybrid doesn't imply how unified it is that you need for actual AI. So they call it more unified AI. So we're going back and forth on terminology. I'm sure someone will figure it out. Even the big the big box guys out there that are very famous for deep learning, Yann LeCun, in his new proposals, if you've noticed, it's all going towards these hybrid AI, that you need to have a cognitive architecture with different kinds of elements. Yann LeCun, the same way. A lot of startups, Schmidhuber, I think, has been exploring this for some time. Minsky, so Henry Minsky, Marvin's son, has Leela. Gary Marcus has been talking about this a lot. We have some papers out there, talking about some of the things that we've been doing, that I've been doing. So that's a little bit of background, I just wanted to cover with you. So let's get into a little bit about this talk about time binding. So let me see if I can share this. This, just wanted to have it in the background. If you haven't heard about Alfred Korsivsky, it's a great question that Boris was asking, is like, why in the world are we talking about something that's this old? I mean, a lot of the work that we'll be talking about with Korsivsky was 1920s, 1930s, even 1940s. It's pretty old. Of course, the age of an idea to me doesn't mean much, because if you look at Fourier's work, for signal processing, or heck, I mean, deep learning is very old as well, right? It's like in the 40s that we started doing basic, neural nets and all that. But Korsivsky, the reason that will be, he was diving into his concern was, how can we come up with an engineering, not really philosophical. I would say that he agreed with a lot of what we've been saying today, that philosophically, philosophical, pursuits tend to be maybe not that practically productive. He was more of an engineer himself, that he was more interested in getting things done. And so he said, how can we come up with a formulation of man that helps us to, or humankind, I should say, human beings, that allows us to understand, understand and describe, have a descriptive model and also a predictive one a little bit better. And so he came up with this definition of human beings as time binding. So I don't want to read this to you, but in essence, in a nutshell, what he's saying is that human beings have this unique capacity to kind of pick up where the last generation completed, right? Or when so he has a very eloquent way of saying this, right? And so that was we have this capacity to do time binding where we can, and you can see how society is continuing to time bind, and our environment now, where even what you would consider people in poverty today are probably in a real sense richer than the kings and queens of even 100, 200 years ago, with all the modern developments of all these affordances that we have. So that was, we have the capacity for time binding. And then he wanted to understand, well, and I mean, he had to came up with this kind of diagram here to just kind of put it in. Oh, sorry about this. Let me go back to this. Okay, so there were, interesting. So somehow the presentation got stuck. Okay, so let's go. So this was the Tesla slide. Sorry about that. There was a technical issue on my side here. I was talking about the energy consumption, and then how Jan LeCun, Andrew Bengio got into that. Here's some of the companies. So the papers that I had. And here's the definition that I was talking about of time binding from Korsivsky. So we already discussed this. But to put it in context with comparing from this kind of definition that Korsivsky came up with and comparing it with other forms of life, he called plants chemical binders, taking different kinds of energy, but mostly the sun, and storing that in different ways. Animals are able to move in space. Of course, we also move in space, but Korsivsky made the point in his book, which we have the references for if you're interested. They're into what is the key differentiation with humans, and that's the time binding property that we've been discussing. Again, the ability for one generation to pick up where the other left off, right? And that seems to be a very, very different, important thing. So he spent his time trying to say, okay, so we have this great, what is it that causes us to be able to time bind? This is a simplification. He came up with something he called the structural differential. There's a diagram of the structural differential. Just to kind of briefly cover what he has here in this diagram, you have this parabola here, which kind of has a top. It's an infinite, kind of real world, if you will, process, that's happening at the quantum level. It's unknowable. We have some links in humans, between these objects in our minds that we create. The kind of the object is kind of episodic memory and other labels and all sorts of things that tie things together. Our mind works a lot in the object space. Obviously, we're not in the process space. He kind of had the animal object over here, kind of indicating that they have limited number. And then on top of the object you have labels. So like say you have the first kind of word that associates with some particular object, and then you can go meta infinitely deep, right? You can have a label that refers to a label and refers to other labels, and it can be very complicated. And then in principle for humans, it seems that there's no practical limitation to our levels of abstraction. Animals, he put in one here, but in fact, I think a lot of animal studies show that, chimpanzees and others, they actually have a pretty deep level of abstraction that's possible, but definitely not as deep as what the infinite levels that humans can do. It's kind of interesting here. You see some of these strings going back and forth between the events and the objects, and that's kind of indicating, these strings indicate like a conscious awareness, right? You can kind of look into like, what do I think when I think of this label? What am I thinking of? What episodic memories do I have? What are my associations? And you can kind of link things back to what you thought was going back into this complex event space. But his view was that animals don't have these links because they can't think about what they're thinking about, right? So this is at a high level. He used this to understand, maybe this is what's happening with man, and he actually created this to help people to train. So that they don't confuse what's coming from this event space, with their label space, right? So with their abstractions, he felt that confusing, and that this is one of the emergent properties of people, in essence, is that yes, well, we can do this time binding because we have this amazing power of abstraction. The problem is that we may get mixed up and start to treat our abstractions as if they were quote unquote real. And you can argue maybe they are real, more maybe that's how reality is generated, all those kinds of things. But in his view, where humans start having problems is when they begin to get confused between their abstractions that they're creating, and you see that a lot, I think, in society today. And they confuse the abstractions with the realities, right? And fortunately, in the abstract space, things look pretty bad often, right? With the news and this and that. But in the real space, when just any people interacting, it's pretty good, at least, so it could be that the abstraction spaces right now are much more negative. So Baudrillard, in the Simulacra and Simulation book that he kind of discussed as well how societies and mankind would probably evolve, and that he predicted that eventually society would get to the point, because of technology, that the abstractions would become dominant over the reality, quote unquote. So he called that the hyper real, right? And he had this, this is a quote, although, I think he was saying it was Ecclesiastes that said it, but he kind of wrote this in his book, and I don't think no one really knows where this came from exactly, but it was in in his Baudrillard's book, where it's interesting though about the simulacra, this idea that perhaps these abstractions don't conceal the truth, but in fact, there is no exactly a true thing. I think Korsivsky would agree that there's no absolute truth, right? The process space, what we know about time and space from Einstein is that, everything is kind of, relative. It's not exactly clear. But, so are there any thoughts so far, or should we just continue?
I missed the definition for on that last slide, what the
simulacra is in from Baudrillard's book. It just means a symbol, basically, like and he was kind of using symbols in religious thoughts about like the statues of Christ, or symbols that could be statues, could be different kinds of things, versus simulation, which is something that's operational in a sense, right? Like a simulation is something you can run and see how it works, but a simulacrum would be more of a pure symbol. So is everybody good with time binding for humans? Good.
Yes, I guess it's very common, and it goes from, I don't know, centuries to nowadays. He's talking about here and now. And sometimes people are so distorted by whatever is going on in their minds and what is the actually abstract reality. And they totally forget that they're safe, nobody physically attacks them, and they're not even hungry. So where is that fine line when we do need abstract reality to somehow being prepared to kind of see what is coming, and at the same time do not lose the animal reality, when we are not in danger. We're sitting now and talking,
Yes.
but I'm sure that everyone has some, I would say, if not worries, but even anxieties about forthcoming future. So
Yes.
how to combine it?
Yeah, and that's actually what he wrote a lot about, and that's what his book Science and Sanity is all about. We also, I put a very short version, kind of re-looking at that problem, because right now neuroscience is looking at something called the cortico-thalamic loop, and the cortico-thalamic loop is kind of discussing what you're talking about, where the neocortex, the cortex is making these abstractions. The thalamus is more, looking at the actual sensory data that's coming in. And what's physically happening in people today, physiologically. So it's not like a simple thing, hey, just do this or just think that, or just don't be worried. It's physically that brains are kind of miswiring in a way. And what's happening is, normally what happens, the way that, the correct operation of your nervous system should be, the thalamus receives input from the world, and then it goes up to the, abstractions into the cortex and the neocortex. The neocortex makes sense of it, okay, and says, okay, we don't have to worry about this lion because actually it's in the zoo behind a cage, so you don't have to worry. And then the thalamus propagates a signal back down to the body saying, hey, don't worry. But unfortunately, what's happening is that the neocortex is seeing a lot of different abstractions, and we're living in a kind of a digital metaverse age now. And so now you're living more in this abstract space. And so now it's the thalamus that's saying, oh my God, there's this terrible thing happening. And it propagates a signal, as you point out, down to your body. And it's saying that I'm about to be eaten by a lion, but you're actually playing a game, or something. You know what I mean? It's
Yeah, I totally agree. But I think also because we have too much information what's going on in the world in general, but originally people lived and they had news about their village, maybe a village across the river, maybe a town, a city, okay, a country, but they worry about some selective things that instantly could be either positive or negative to them. And now when we're talking about, I don't know, starvation in Africa, I do not want anybody to starve, but do I need to worry about it right now and feel bad and see all those pictures? Like, I do not want to sound selfish, but certain information is not necessary.
So here was Korsivsky's solution, right? He actually created physical versions of this, so they were a little bit more complicated. And the idea was that he said he trained this. That's the whole. He created an Institute of General Semantics, okay, and it's all about training people to be aware of their abstracting process. So, like, for example, you have a ton of information coming in, you have a lot of abstractions coming in, but if you're aware of how your brain is working, how your brain is producing these abstractions, then you can have your neurology work correctly, and it won't bother you that something's happening across the world or in outer space or something like that, because there's nothing that you can do about it right now. So it just allows your nervous system to work correctly. In his experience with thousands and thousands of people and of all ages, from children to adults, he found that he could train, he could get kids to understand this and change the way they worked, to much healthier neurology very easily. But adults take a year or 2 years of doing this very rigorous process. Adults, because we're already kind of, have certain connections and neurological ways of working that need to be changed. But this discussion was really intended to take this idea of time binding and see how it relates to AI. But that's a very, I love that. I love that discussion there.
It looks like Boris has a question. I didn't. With the raise hand feature. I don't know, Hugo, do you want to call?
Yeah, I can't see those. So if you could just,
okay.
Yeah.
I guess I'll let you.
Thanks, Mike. Regarding the thalamocortical loops, thalamus doesn't do much of value judgments and so on. It basically more like a crossbar that connects everything to everything else in the brain. It does mediate sensory input flow, but it also mediates higher order loops in the cortex It has first order relays, it has second order relays, and they really have nothing to do with the senses. It's not, if you're looking at value judgment, you're basically looking at the head areas like brainstem and limbic system. Thalamus itself, it is an interesting part, but it basically selects, kind of prioritizes whatever thinking thread that goes on. It has, I think it is this attention part, but that attention could be purely cognitive. It could be those higher order processes in the cortex that just kind of feed into each other. It doesn't have to be paying attention to anything else. You have this, it's more like a mediator of winner take all in all kind of processes that goes all across the brain, including the cortex, especially in the cortex, of course. So by itself, you know, those primary relays, the first relays, is very small part of the, relatively small part of the thalamus. And it's relatively small part of what the cortex does. Most of what the cortex does is just feeding into itself. You know, it does feed through the thalamus because you do have to make sure that that thread is still kind of highest priority. But again, that winner takes all in priorities doesn't have to be with the primary inputs. It could be between. It's more like a battlefield for all the thought processes that goes on in the radar, regardless where they come from the senses, or it's just those feedback loops that go through the cortex.
But I don't know that we want to dive into the thalamocortical loop. It sounds like there's a lot of potential discussion there, but those are interesting.
All right. So another thing is about the time binding. From my point of view, I see everything as clustering, and time binding is essentially one-dimensional clustering. You start from multidimensional input in space-time, and then you do dimensionality reduction down to a thread, a trajectory, let's say, of, let's say, or action, okay? Because basically the brain evolved to guide the body. The body can only do one thing at a time. So you have to sequentialize the process, even though cognitive process by itself is massively parallel.
So Boris, so are you saying that do animals do time binding?
Of course. I mean, they have to go someplace, right? That the action is a sequence.
So you're saying that animals are able to build civilizations, and you know, one generation.
If you have this multi-generational learning, which is not really changing the learning process itself, it's more like...
No, we're not talking about the learning process. I think this is a very good point that you're raising. It's very important because, you know, the reason that we don't see like advanced technologies emerging from the animal domain is exactly because of the time binding property. So any time binding by the definition that we're using here, it would result necessarily by artifacts like high technology evolving, like humans are doing. So continually evolving, sciences and arts and technologies, all of those things are a mandatory requirement by Korsivsky's definition of what it means to do time binding. It's not about the learning process at all. I agree that the learning processes are all there in animals as well, but that's why he made the distinction.
I don't think he was not an expert in neuroscience. He was not an expert in computers.
But if you notice the definition, it doesn't get into neuroscience. And he didn't talk about cortical-thalamic integration. That was not.
I don't think he was an expert in anything related. His field was totally different. I mean, seriously, that time binding is a problem that has been beaten to death for millennia.
Well, okay. Hugo, why don't we move on?
All right, sorry.
Right. So, but at least we're clear on the definition, right, Mike? On the time binding definition, this idea versus the animal. So yeah, the learning process is time binding. You know, is not something. Unless, does anyone want to argue that animals are doing time binding? No? Okay. Yeah, yeah.
You can't do anything without time binding. You have to, the animals develop the brain to act. Action is a temporal process. You have to time bind. That's what the action is.
What is your definition of time bind?
Again, it's just one-dimensional clustering. That's all it is. You start with multiple.
That's not what we're talking about. We're not talking about one-dimensional clustering.
I think it's a matter of interpretation.
Okay.
So-
Okay. Well, that's completely wrong. For the it's a very different definition than what we're talking about here. So maybe not wrong, but just different. So here we're saying that time binding has a certain definition, very simple. You know, it requires that a species or whatever it is that's doing the time binding continue to evolve their language, their external artifacts, all that sort of thing. So it means
Animals
that
do that too. Animals do have culture. They do pass the knowledge through
technology,
generations. They have technology. They do have technology. They just don't do it to the extent that we do. The difference is in degree.
Yes, yes. And that's what we're trying to make the point is that the key differentiation, the reason that you don't see, you know, automobiles coming from the animal domain is because of this time binding. The reason you don't see the evolution of you know, all the sciences that humans have is because of this time binding. It's just a definitional thing. But you know, if you want to,
It's not. It's a matter of degree. It's not a qualitative difference.
Okay, Boris, we're gonna let's move on. I think you've made your point for now. So Hugo, why don't you
let's agree to disagree on that and completely disagree that it's one-dimensional clustering, because there's no way that you can capture what we're doing here with one-dimensional clustering, but it's very interesting. Okay, so yeah, in the AGI concept, and again, I'm gonna say there's a time binding Korsivsky, which means this idea that you know, say a race or species of things can pick up where the prior one left off and develop advanced technologies exponentially, right? So exponentially changing the environment. We have not seen anything like that. It's not qualitative, it's completely quantitative. The difference that humans are making in their environment is exponential. Whereas without time binding, which is where the animals do something, like they definitely abstract, as we mentioned before, they have a lot of this, the learning processes could be, you know, very similar, all of that. But once you get to time binding, your impact is just exponential. So maybe there's a time binding Boris, which is very different. You know, it's going to be one-dimensional clustering. It's going to be everybody does it. You know, all animals do it. And then there's Korsivsky, which is only man does it. That's a very, very key distinction. There's a time binding Korsivsky. And in the context of AGI, so here's some of the steps. I think that we're already, you know, into the space of hybrid AI or neurosymbolic AI. You know, you have machine learning, deep learning, you have you know, new kinds of reasoning systems, you have models for knowledge, self-supervised learning, cognitive architectures, hyperdimensional computing. It's kind of all this hybrid AI is already taking off. One thing I think that we are still you know, a lot of the neurosymbolic systems definitely have you know, the lifelong learning, where some animals do that, you know, for sure, where during the life of the animal they continue to learn. Yeah, did someone say something?
I think somebody was unmuted, that's all.
Oh, okay.
I'm not sure how to mute people from here. I don't get the command for some reason.
Was there somebody who wanted to say something, or Boris? It sounds like we have some major disagreements there.
You know, I think
Sorry, I better butt out. I just don't see it as a qualitative difference. You have the same mechanics in the brain. You basically have the same process in the brain. You have culture in the animals. You have technology in the animals. It's just a matter of cumulative, okay, because it's kind of feedback loop. It's more efficient in humans, the intergenerational knowledge transfer. And so it accumulates a lot faster, it becomes exponential and all that. But that's a degree. It's not.
It is qualitatively different. In my view, I would say that the impact that humans have on the world, the level of knowledge that we have is qualitatively different than what we see in the animal domain. But you know what, we're not going to answer that. I mean, I totally agree that you have your viewpoint, I have mine. I'm talking about when you do your timebinding.boris, we can talk about yours more in more detail. I think we get your point though, right? That,
Yeah,
you believe they're the same thing. But for this to work though, the time binding is actually the heart of what I'm talking about here. And it's not something that you can just say, oh, well, any learning algorithm that's similar to what animals do will automatically do time binding. My whole point is that we need to explicitly talk about how do we come up with AI systems that explicitly support time binding. So that's a really, core piece of this, of what I want to get to. Were there other questions, other comments? Okay. So we have I would say that when we look at, how do we get to more general intelligence, more that for example, could support driving your vehicle safely in very complex environments, even if it hasn't seen anything like that before. Lifelong learning is something that a lot of the neurosymbolic and architectures out there support right now. So we have Open NARS, we have Kristen Thorson with ERA, OpenCog and Hyperon. It looks like they definitely do lifelong learning. So this is cumulative learning, which, as you know, with machine learning, deep learning today, for the most part by itself, you have the problem of catastrophic forgetting. So lifelong learning for those systems, these neurosymbolic systems, is something that I would say they're demonstrating that we can have that capability right now. Explainable AI, again, for neurosymbolic is happening to some extent. Whether this is all happening in a self-supervised way, I think is still something we need to get to. But what I want to say here is that time binding AI would be a little bit different, than all these things that we've been discussing so far, in the sense that now you would have, similar to time binding for humans, where one generation can teach the prior generation, or the prior generation can pick up where the current generation left off. We don't really see that in AI systems today. It has certain, it obviously would be very efficient if we could do something like that, and it would help generating and training all these models that we need. But it's there's a few requirements that we need to get to make that happen. So a little bit more on what I want to talk about with time binding AI. So enables AI systems of different types to time bind. I think it would be kind of maybe you could argue trivial to say, okay, the same type of system, just has to store its memory, then recall it. But again, you'd have to solve the catastrophic forgetting problem that you see with machine learning and deep learning. So it has to have some sort of knowledge representation where you have clear views on abstraction about asymmetric, antisymmetric, and symmetric relations. All those things. And we found that they're pretty important. Causal modeling has to be in there. Explicit direction, right? It's like what causes what. You don't want to be a lot of the systems can tell you there's a correlation, but causation requires obviously more causal modeling. Built-in explainability, I think, is pretty crucial in the kinds of systems that we're working on. So in order for a time binding AI to work, the teacher system has to have some model of what the student system is capable of. What is the the spatial temporal prior, if you will, of the system, right? So that it can actually synthesize, create synthetic data, or train the system in some way that makes sense to that system. So some way of modeling spatial temporal and other kind of core concepts are kind of crucial in time binding. With humans, it's more straightforward because we all have so much shared experience being similar species or the same species, right? So that helps there. And then it's kind of the systems, it involves some sort of a generation of data, a curriculum for the student to learn. So in terms of as we think about next steps of what's happening, what should happen for AI, this concept of active metadata, I think, is going to be potentially where big business and the AI community meets. Active metadata is something that's top of mind for big businesses right now that have what's called data fabrics, where you have distributed data, edge to the cloud, massive petabyte, so huge data, but it's highly distributed. And then you begin to create, stores that not only tell you what the schemas are that tie everything together, so you can do, queries across the thousands of tables that you may have, but you activate it by continually automatically updating the metadata by some sort of MLDL or to some extent potentially manual processes. So active metadata with a data mesh, I think is going to. It looks like it's estimated to be hundreds of billions or $1 trillion dollar opportunities out there for whoever can do that. It's not a solved problem yet, but there's a lot of solutions that are out there for big business that are trying to get to this active metadata. The idea is that you get real-time data-driven insights from something like that. Another thing that we've been doing more work with a lot of research is safe autonomy, right? It's how do you as you have, your intelligence may be goal-oriented or it could be open-ended. If it's open-ended, there's more chance that it may not do exactly what you want. So an open-ended, say AI for driving may decide that, may have interesting decisions that it makes about what it wants to do. So you want to, so in these contexts, how do we kind of keep things from an engineering perspective reliable and safe, right? So safe autonomy is kind of an external building block that allows you to formally specify what is the kind of behavior that you definitely don't want the system to do, and it kind of sits outside of the system itself, between the system and the real world, and so that part of the control, closed control circuits, right, where you have something that can just help to limit the range of behaviors into something that you want to do. So there's a lot of work being done there as well. So were there any other thoughts at this point? Active metadata, as I mentioned, here's just a quick diagram on that. It's a remarkably in line with what a lot of us are talking about right now, building. So we've built these hybrid systems with models of knowledge, solving all sorts of problems from networking to vision and smart cities, and they're working well today, just empirically. So they're actually doing that. But active metadata, I think, is a platform that just seems to be what businesses in general are going after. This is one of the researchers that we work with, Sam Coogan, on the autonomy side. So I think we're pretty much, I think I've gone over time here, but in a lot of Cisco applications, we talked about some of the elements that we have. So I'm not talking about theory, I'm talking about systems that we've deployed. We've had like smart city neurosymbolic systems deployed for a couple of years now. We're having some amazing results with this in cases where you have a lot of time series. There's some references in there, but yeah. So would love to collaborate. Part of Cisco Research, we fund partnerships. Mostly university research projects. I'm personally very interested in this whole AGI space. So that if you have something that you want to collaborate on, let me know. And with that, I don't know if there's any further discussion, but I think we're well over time, right, Mike?
Well, no, we've got until, oh shoot, yeah. No, we've got quite a bit of time left. Okay. I scheduled it out for till 2:30.
Oh, okay. So maybe it's just open discussion. It would be good to get other thoughts. It's clear that there could be different definitions of time binding. I'm not going to argue over definitions. I'm just kind of telling you the definition that I'm using for what time binding is. But are there any other thoughts?
Hugo, can you hear me okay?
Yeah, I
Hi.
can hear you. Well,
Yeah, I missed the very first part of your presentation, but were there certain books that Korzybski was influencing your work, or
yes.
you recommend?
So we have a few references, but his main work is there's two works I would say. Manhood of Humanity.
Right.
Kind of, so he was arguing that. Are you familiar with Korzybski already?
A bit, yeah. I haven't dug too much into his work, but I'm familiar with the diagrams from the Manhood of Humanity.
Oh, good, good. You know, and so there he's kind of formulating the problem, right, and saying that
Mhm.
you know, so how do we get humanity to go to be more aware of how our brain is abstracting so we can solve some of the problems? The other one is science insanity, where he gets a lot more into the abstracting processes in his model. So back in the 80s, you know, mid 80s, there was a company I was at where we used some of his ideas for modeling abstraction and knowledge to begin to do this kind of active metadata sort of idea, right? So yeah, so I would say science insanity, but they're kind of long. Well, science insanity is a long one, right? That's a read.
Great, thank you. And was that DH4 you mentioned? Is that another metadata schema or process?
DH4.
Did you mention that? Sorry,
No.
maybe I misheard.
You know, I don't think I said that one. No,
Okay.
so we have our own meta model that we're using where, you know, what we had before when it was pre-RDF, right? It was the mid 80s, so there was no ontologies, there was no RDF. So we had this semantic model that was a little bit different that kind of solved the SQL, no SQL dilemma, right? Where how do you deal with how do you do fast queries and indices on data that's not structured? So we have that, you know, you can, if you look it up, the metadata.com. But yeah, if you look at a couple of my publications, you can see some of the thoughts that we have on how we took some of these ideas of Korsivsky and abstraction on our knowledge, on the meta model that we were using, the model for modeling knowledge. Yeah.
I'm glad that you mentioned semantics, because when we were talking about abstraction, animals, humans, the main thing is our language. And obviously, time binding is developing of our language from generation to generation, which
Yes.
is absolutely doesn't apply to animals.
And Boris may disagree with you.
and basically, yeah,
Yeah.
the cat is still meows. And so far, we develop our language and we create symbols, and the symbolics and algorithms at some point we created it, I mean humans, and then those symbols affect us and they kind of take over, right? It's religious symbols. Basically the icon by itself, just a piece of wood and beautiful image of Christ, doesn't have a power, but our inner, we can discuss it maybe for hours and hours, what we put into that icon, that's what affects us.
Yes, yes.
And
it would be nice. It would be nice if we could just become more aware of that abstracting process and maybe more in control, so that we don't, you know, get caught with situations where you know, like you were saying, your abstract processes and reasoning are dramatically adversely impacting you physically, right? And that's what
yes,
yeah.
That's the whole problem. How can we control our emotions, our just overall inner being from bombarding information and processing that information?
And solving that was the whole reason for the Institute of General Semantics, and as the name of Korsivsky's book, Science Insanity, kind of implies. It's kind of it's exactly applying science to how do you know, can you behave, you know, in a sane manner.
It's a little bit scary.
Questions? Okay.
For me, it's a little bit scary when somebody outside with artificial intelligence is trying to solve what we were just discussing. This is very scary. So if they try to solve my emotional problems and how to do it and how to control and how to process, it means that I'm controlled and processed. So that's why I was listening. It's super interesting what you told about all the development and discussions and study about physical and abstract technology. And somewhere inside, with all my maybe ignorance to modern technology, I feel kind of alarmed, because will it be again input on me to control my emotions and to control the information I am receiving and my reaction? And what is it, abstract technology that will be used on me eventually?
Well, hopefully, I personally will not be signing up for those brain implants. that Elon does. But, I really, if you have interest in this space, I think that obviously Korsivsky's point was he was not interested in artificial intelligence. It didn't exist back then. Even though his ideas, about how, a generally intelligent agent could operate optimally in an environment, or as a species, that is super applicable to what we want to do with artificial general intelligence. But if you read his work, though, it's really mostly about, and he has helped his work has helped thousands and thousands of people to just, it does change how you, how your neurology actually works, so I know people that bought that structural differential, like those diagrams, and they actually have to, there's physical implementations. You have to kind of like physically play. There's some exercises that he kind of hints at in his book, but thank you.
It's a form of therapy, I think.
It is.
Yeah, that I was reading. Any other questions for Hugo? What I like about this is that it starts kind of in a holistic fashion. So it's got like that diagram you showed early on. It had at the top of the diagram this kind of like a hole, and then from the hole we take the abstractions. And so in a way, it's kind of an inversion of old AI. Old AI being you start with the abstractions. So I can see how it fits with better AI. And
Mike, let me ask you, does the time binding concept that I'm trying to kind of talk about here, just as, so I'm defining it, so it's not really an argument, it's like an axiom. This is how I define it, and I'm defining it as Korsivsky defined it. Does the definition of time binding, is that making sense? Or is there some part of it that just is not clicking for you? What do you think about the time binding?
Well, I guess what I missed was how do we get to better abstractions? I can certainly see the need.
Well, how about this? Can someone, maybe tell me what they understand time binding to be based on what I said, what Korsivsky's definition of time binding. I just want to see if maybe I'm not, didn't get the idea across, that well.
Well, if I may,
so sorry, Boris. I know that you have a different definition, but
it's kind of different. I'm of that.
Yeah, but I'm very interested, Boris, if you don't mind. Does anyone, maybe want to just say, did this time binding, for people, does that part, the definition that I'm saying, does that make sense? Or is it still kind of not clear what we're talking about there?
The distinction I got, the main one was that a person's knowledge can be transmitted to someone else.
That's kind of the key idea, right? So if you think about, the arguably 10,000 years of, human civilization, or 20,000, whatever, how we continue to kind of evolve, right? So why is it that now we're so advanced? If you look at your environment, most of what we see around us, wasn't around a couple hundred years ago, right? So yeah, that actually leads and what Korsivsky also shows, which we didn't dive into, is how that leads to exponentially, different outcomes when you have this time binding, idea. So yeah, so that's exactly right. So it just allows, one generation picks up where the other one left off. And
maybe during the Korsivsky's time, it was still time binding ties between generations. But now I see that it's broken.
Oh,
basically,
yeah. He said, by the way, one point there, he said that we have the capacity for time binding.
We do.
But I would totally agree with you that I think we're not doing it anymore.
I think maybe we will restore it eventually. But at this particular point, I see it very clearly that time binding with the previous generation is totally broken. And I'm not even mentioning generation of the grandparents. It's broken. If somebody tells you about so-called alternative medicine, it's not alternative medicine, it's just traditional medicine. So even terminology, semantics, what Korzinski was talking about, is twisted. So
Yes.
that's why it's
And
super.
unfortunately, you know, with the internet and the optimization of trying to get clicks and trying to get attention, it's what the algorithms have done is that they've learned how to play directly with people's neurology, right? To kind of get you excited and upset, and so you be to react more and more and more. It's a little bit of an interesting question. So, Mike, if you don't mind, I want to ask you another question.
Mhm.
So Mike, so you get the time binding concept as applied to people. Does this idea of applying time binding to AI, do you understand what that's about? Does that make any sense to you? And I'm just kind of using you as a proxy. If anybody wants to jump in, please do. But I just want to see if you know, I need to kind of alter how this is the first time I try to describe these ideas.
I mean, it seems cool. I mean, what I think what the real objective is to be able to transmit knowledge, say, for instance, from one AI to a subsequent one in a correct fashion.
And it could be a different one, right? So it could be a different type of AI system. Like it could be, yeah. So that's definitely part of it. And the idea is that just like with humans, where you get this exponential, you know, growth in the impact and the development of these systems, when they start doing that, because right now, I mean, all the learning for the most part is a highly computationally and human resource intensive, you know, process, right?
And not easily shared from one system to another.
No, but let me ask you this though: what's the difference then between, say, cumulative learning, lifelong learning, and time binding? Aren't they the same thing?
It sounds like the distinction
you know,
is that it sounds like the distinction is that that's true. Cumulative learning would be important, but can the cumulative learning be transmitted to the next agent in such a fashion that it
so exactly. So if you look at machine learning, deep learning systems today, yeah, they have a very hard time with cumulative learning because they suffer catastrophic forgetting.
Right.
When you just kind of, you know, train them with the new data coming in, so you have to train them on everything. But there's obviously some progress in that area. But having an animal that can continue to learn throughout its lifetime is still very different than having this time binding property, right? So yeah, so you got that. Okay, so that was the whole. I wanted just to make sure that at least some of the basic ideas we're getting through. I've never tried to talk about this too much, this time binding AI. It's very interesting that there's you know, some debate on some of this, but lessons learned, definitely.
I mean, it sounds like time binding. You're kind of using that as a general definition to encapsulate your whole concept of being able to accumulate knowledge, to be able to understand it, and to transmit it to the next agent. Pretty much. So, so when you say time binding, you're basically talking about the whole thing, the whole.
Yeah. So for an AI to time bind, it has to have all these elements, right? You know, that you mentioned, definitely. And that's why it's kind of an evolution.
Yeah, and it's a good keyword to kind of focus on.
I think the term is misleading. That's all. The term time binding AI is misleading. It's going to confuse people.
Tell me, what was your first? How did it mislead you? Like, what did it evoke?
I thought of you know, having experiences and that occurred in different time periods or something like that, or having thoughts about things that happened at different times. So in AI, you would keep a record of the time an event happened, whether it was a sequence or, you know, whatever.
So the problem is, yes, even though Korzybski came up with this term, they're already well-known terms, and people will have different associations with it. And that's a very good point. Probably, I think that would have, if I would have called it something else, brand new, there may have been less problems in this conversation today. Yeah, no, that's a great point. Thank you for that. I'll try to maybe come up with some other name.
Well, time binding, that's his term pretty much. So you're just staying true to the doctrine.
I am, but we don't have to use his term if it already evokes problems.
Well, I think everything evokes problems. I've never heard of anything that didn't.
Well, no, the way to not everything. If you come up with bloodity blah, does that evoke a problem? It's just a new
What?
term, right? I mean, you could create a new word, is my point,
Yeah.
right? Well, so with
But it's
no
all see,
prior.
that's why we have philosophy to discuss the nature of crazy.
By the way,
world.
Korsivsky thought that philosophical pursuits were largely a complete waste of time. So,
You know,
If you talk about time binding, do you mean time awareness rather than time binding? If you
No,
say
no.
time binding, then I think about data structures, SQL, database,
Time
that kind of
series,
stuff,
you think time series.
relations based on time and position and time.
Yeah.
But time awareness is still
No,
something
this is not about.
different.
This is not about time awareness. No, it's not about. It's purely about Korsivsky's definition of an entity's capacity to learn and then to transfer its learning to another, similar entity, right? Just this time binding piece, so that generation after generation, you get these exponential benefits as the learning just goes through the roof, right? So you're right, but it's I could see how the time binding term itself. Maybe we need to. If there's any proposals for, please email me, or you have a better name. This is kind of the first time I kind of tried using the term, but I'm trying to learn from this experience here, and I think all the things that have been raised here would be raised in other contexts where I need to use this. So I'm gonna see if I can come up with a different name. I can still refer to Korsivsky's time binding as the inspiration, but we don't have to call it time binding if it has so much. Seems to be a problematic term in my view.
I think it's a fine term. Originally, it was folklore. It was time binding. Basically, people were retelling stories and legends and about heroes and history. Then when people started writing, they started writing history books, and it was time binding as well. Then, of course, all kind of serious researches and books and Korzinski, and he just put all together and made a very interesting statement about all of us creating symbolic algorithms and trying to basically help ourselves in some way to deal with what we're going through right now, using all the previous generations' struggle in the same attempt.
Yeah.
I had another question. I guess if you had what is the distinction between this sort of transfer learning or transfer of knowledge between similar species or similar types of entities, say between humans, versus us trying to teach our dog, or us trying to teach some type of artificial intelligence that is not maybe not neurologically based, or doesn't reflect a lot of our cognitive architecture.
Right. So the definition that we're going with, if we go back to, I'm going to stick with time binding, Korsivsky's time binding definition, is that each generation can pick up the pretty much the entirety or at least most of what was learned by the prior generation, and then build on that and go on with that. So first of all, a dog is going to be very limited in scope. You're not going to see that. And if you stick to this idea of similar entities, ideally that can continue to kind of absorb much of the learning that each entity learned during its lifetime and transfer it over, and then keep growing that knowledge and expertise, and also impact on the environment and all that you with a very little modeling, you could see that you end up having exponential impact of knowledge, exponential impact of technology, of the way that you're the way that these entities and their environments live and interact, right? So with where you are showing a dog, say, how to go pick up a stick, the dog is not going to pick up on your entirety of your knowledge and then go and then learn how to extend Proust, or whatever it is that you've been doing, right? So so that would be one case. And so yeah, so the idea would be that since we're focusing on this exponential growth of knowledge and technology that happens when you have Korsivsky's time binding concept. When that whenever that exists, if you have a bunch of machines now that are time binding, between themselves and maybe thinking at several trillion cycles per second, you can envision how things could evolve much more quickly. I don't know. So I don't know if that makes any sense. So Dan, did that make any sense?
Yeah, I think that makes sense. And then to maybe a pivot off of that question would be, does this concept of time binding, if the AGI is kind of self-aware of the techniques it's using, does that aid the AGI in trying to, say program your VCR or program, lesser type of machines the way we would kind of program our dogs to do things? Does it help in their understanding of how to be explainable?
I think you raised a new thought there that I hadn't actually, I was not thinking about, where there's such a dramatic difference in the capacities of the systems involved, right? Like a dog and a person, or a VCR and an AGI with 1,000 IQ, whatever. The reason that those scenarios are interesting is because in business, say that you have, and we're building this kind of time binding, AI right now. The most applications that we see, because the world has GPUs and existing hardware, existing software, they can easily run TensorFlow and PyTorch and all these kinds of MLDO models. So there's a huge value add right now, from a business perspective, from a societal perspective, to be able to create these capabilities, right? Where you have a system that understands different capacities of what's happening, So even just, for example, if you consider artificial intelligence at the edge, right? So like people's devices, or at the edge of the network devices, so the consumer edge or the network edge, so a lot of different places that things could be learning. What we're finding is that and the real world evolves all the time, right? They're non-stationary time series, and so nothing is repeating. So there's a need to, if you deploy something that works really well, some AI, some models, deep learning models that work really well, without time binding, or some system that could train these things automatically, you're going to spend all your time training models, because every week they have to be up, or every day or every hour have to be updated.
Oh, wouldn't the idea of learning from your mistakes fall under your time binding?
I would say no. I would say that in the strictly what I was thinking here, that the learning from your own mistakes, like animals definitely do. So in this case, totally agree that animals are doing this for, hopefully. I mean, a dog may take 5 times to learn not to play with skunks, for example, but it does learn, right? So I would say that's in the lifelong learning or cumulative learning category, which, by the way, is still, I think, considered generally unsolved, right? But for a lot of the neurosymbolic people, or hybrid AI, whatever you want to call it, cognitive architectures, we would say that it's a solved problem.
Yeah, like, so Dan just commented, maybe learning from the mistakes of others.
So that's interesting. How would you classify that? Are there some thoughts on that? So say that you're learning from the mistakes of others. I would say that animals can do that, and they don't exhibit the Korsivsky's time binding principle. So I think that you could say that still would go in the category of cumulative lifelong learning in the framework that I'm discussing. And as you know, with the brain's mirror neurons, that when a primate looks at somebody, another human or a primate doing something, they can actually physically experience, like, if it's actually happening to them. So it's kind of like if they're learning from themselves doing it, just because of the way the brain is wired. That's an interesting question, though. I think this is all up for debate. I'm kind of proposing terminology right now, which I'm kind of questioning whether time binding is the right term. I would like to have everybody be happy with the term. It seems like some people aren't. But,
well, the term is fine. It's just a couple of words that you put a specific definition on. I'm just trying to figure out what are the limits of your definition.
Yeah, no, that's good. That's good. So is it clearer now, or do you disagree with my idea that in the case of an agent learning from another agent, that you could still categorize that? I mean, by observation and by action, not by language. Maybe the key distinction is how did the one agent learn from the other agent, right? So if one agent learned by the mistakes of others by observing the mistake through direct sensory input into whatever sensors the system has, I could say that that could fit into the category of lifelong learning. If you're learning from others' mistakes through language, then perhaps that's more of a time binding. Now,
okay, then I guess I would have to say that it still applies to animals because they can do that.
yeah, I know, bees, right? I mean, in a lot of cases they can do that, this sort of thing, but they're still not time binders. So then I would say then you probably what you're suggesting, I made a mistake, because the technical definition that we need to continue to apply to Korsivsky's time binding that we're using here, as applied to AI, is that this exponential growth in learning and technology, et cetera, knowledge that occurs when an agent can fully absorb the knowledge of another agent and continue to learn from that point. And that's not something that animals are doing, right?
Well, they're doing it, but just at a different level, a much lower level than we are.
Yeah, you definitely. So I guess the question is, what exactly, where is the precise distinction where these behaviors of animals, because you don't see the exponential, results of time binding that you see with humans with the animals, right? So what exactly is that point where it's not? It looks like infinite levels of abstraction, versus a limited, finite set, fairly finite set of levels of abstraction is part of it. I don't know.
Does it require a discontinuity in the time of observation, like like immediate observation versus reading the mistakes of Stoics 1,000 years ago? Or is
I don't
that?
know. I don't know if that's a requirement, for it. I mean, if a bee could kind of explain to another bee like all the great ways that it learned about a certain space and how to build the optimal beehives, and then the other bee can take that knowledge and then create like a new generation of beehive. I don't know, but it doesn't seem to work that way.
Mm-hmm. I think time binding for animals based on biological survival instinct. And that's what mother dog will teach the baby dog. But if you train animal to perform in the circus or live with humans, mama dog will not teach the same tricks to her baby dog. So basically, animals do have, if you use this terminology, time binding, but it's super limited, it's just for survival, and it goes from generation to generation according to the circumstances, if it's a forest or it's a human inhabited, and they learn how to live there.
So Tatiana, though, the key part of this definition, right, is that you have to see that there is enough transfer of information for this time binding, Korsivsky time binding, that you have to see exponential growth in knowledge, exponential growth in technology. And by that definition, do you see that in animals? I don't think we do.
No, absolutely not. I agree with you. That's what I'm saying, that for animals, if we want to say that, oh yeah, but some animals do teach their babies to hunt, to run away, to, I don't know, behave and to save them. But it's very limited. It's just biological kind of instinct to save the younger generation. Humans have the ability to develop to the extent of destruction. We do not discuss now if it's good or bad to develop it to a certain point, but yes.
Maybe you, by the way, it's impossible for us to know if there are animals that are time binders, right? Like, for example, say that dolphins, which have much larger, brain capacity than we do in general, mostly because of their echolocation and all that. But say that, that they had developed very advanced, knowledge and continue to advance their knowledge, but we can't even begin to understand it. We don't speak their language, so it's possible, right? So I don't think we're trying to exclude the possibility of some animals, and maybe we just don't understand it well enough yet, right? It's possible.
C.S. Lewis, right?
Yes.
So how all those talking animals in fairy tales, it's our fantasy, and I love it. And I love this combination with folklore and Christianity and paganism and all those amazing animals who understand you and help you and talk. So it's fine. Maybe in some future we will.
And certainly, if we're talking about time binding with systems and you know, primitive hardware and things that were developed in software, why not animals, right? I would say that.
Oh
would,
yeah. If my refrigerator can talk to me, telling me that I need to, I don't know, buy milk in the future. So I guess animals will talk too.
I just want something that can drive my car reliably.
Really?
So you do not rely on yourself anymore?
No, it's just that you see that so much benefit, you know, because at that point, you know, people don't have to own a car, right? Because now you can have a amazing automated, you know, models for getting you from one location to another.
You know,
so there's a lot of other major uses, right?
Yeah.
So there are a number of robot taxi systems operating now. One in a couple of them in San Francisco, Phoenix, and Austin.
Yeah, a lot of horror stories too.
Well, there actually have been working for a while.
Yeah,
you know,
there is if I can tell you a little bit about that, I've seen that, knowing some of the people that are, you know, doing this, that what appears to be fully autonomous is often still a little bit of human guided remote control, right? Where they get all the sensor data coming in, there's somebody, you know, handling some of the tough cases and all that. I personally, I'm a little bit skeptical that the current technology that we see with AI is going to be doing like really reliable, safe, you know, fully autonomous driving. I think that's going to require more along the lines of what we're talking about here. I mean, think about it this way: when you talk about the sequence of capabilities that we would want to have with an AI system, they're not even explainable, right? So you have a system, you have an autonomous driving system. It doesn't do cumulative learning, doesn't really do explainability, sure as hell doesn't do time binding. Very primitive still, I think.
I agree with you. And also from the human point of view, I take taxis in so many foreign countries, and you cannot imagine how much I learned from the taxi drivers. It's so much fun. Even if they do not speak your language, you know much more than from the social media, what they think, how life is going on, what they think about the US, what they think about life. So we basically abstract ourselves, but by this modern technology. I do not want automated driver.
Well, as you get a little bit older, you really want them, because it's getting pretty scary out there.
Maybe, but you know, it's kind of scary to sit in an automated wheelchair too early and be driven, not drive. I prefer to drive. I am not a great driver, but I prefer to drive.
Any other questions for Hugo? We got about 15 minutes left. Anybody?
Hugo, what's your I guess what's your ability, your possibility for working with independent AGI researchers, such as many of us on the call right here?
So I am extremely interested. Please contact me if you want to you know, find some way to collaborate. Yeah, I think we could definitely. There's a lot of there's different paths forward. You know, if you have some kind of system, or you want to maybe if you're affiliated with a university, you know, contracting positions, or different ways.
Okay, great.
Yeah, please contact me.
Thank you.
Hugo, do you have other desires than business desires in this topic?
Other desires than business desires? Yeah. So the question is, you know, this is not for me. This is not about business. Okay. I mean, of course, if you can make a few billion on the way, that's great. You know, but the work that I you know, I'm trying to actually, one thing I'm trying to do is revive Gorsibsky's work right now, because if you understand what he was trying to say and his solutions, and it's actually not that complex, but I do see that we are in this age where it would be useful for people to become more aware of how they're abstracting, you know, so that they can have healthier, happier lives. Because I see a lot of people very stressful, very, very miserable, And it's mostly because of this abstract, it's almost like the technology has adversely impacted society in many societies. I'm not saying everywhere, and I'm not saying everybody, obviously, but you do see all the negative impact of technology. And the other thing is, I think that we're facing some big problems as a race, technological problems with, warming and so we need to have more intelligent solutions for energy, for autonomous systems, So I think this work is really crucial. I mean, we need to get AGI working. So this is really, money is not my primary motive at all. The only reason that's a good point though. The main reason I mentioned this active, active metadata idea, because if we can get AGI, and the reason I'm actually, discussing this is like, how do we build this AGI? Say we agree that we can all see why we would need, smart, intelligent vehicles that could really drive you autonomously, right? Or smart robots that could really, take care of elderly. I mean, you see the demographic shifts, in many countries. Everybody's getting older, Japan and the US, everywhere, and you need more workers to do, so you're going to need more intelligence, kind of assistance, everywhere. So there's a dramatic need for this. So if you do believe that, say, AGI is an important thing that humanity needs, to solve all these kinds of problems, then you also probably want to think about, well, then how does the AGI effort get a lot more money, right? And that's what excited me about this active metadata, because in fact, in realistic terms, right now people will not get billions of dollars for. I mean, yes, Microsoft said they're spending $1 billion on AGI, right? That's true, but I think you need hundreds of billions, $1 trillion because I think all the elements are there. There's a lot of great building blocks ready to go. My concern is that there's too much hype around some of these things, right? I mean, I love machine learning, deep learning, large language models, diffusion models. It's huge results that we're seeing, but there's too much hype, right? So that's a little bit dangerous. So the reason I mentioned this active metadata, because I think if we apply the building blocks that we have today, and we address this business problem of large scale data fabrics for large enterprises and active metadata, which I think is a natural thing, you'll see billions and billions and billions of dollars, to push AGI forward. So that's kind of my motivation. If it seemed like would I mind to be a billionaire? Of course not. I do like money also.
So are we going to have access to your charts after this?
Yes.
Okay.
I can post them.
Yeah, I'll send them to you, Mike.
That'd be great. Any other questions?
Go ahead.
Did I understand you correctly that you started the last statement that as we are getting older and obviously we need more help and stuff and agencies and this kind of modern technology and research will help us and something like that. But I want to ask you, what about time binding with the previous generation? What happened with being helped when you are aging and you cannot drive your car by your children, grandchildren, friends, I don't know, your community, your church members.
So one of the things I'm working on, I call it the exocortex. I've been working on it for like 20 years, and it's my own kind of AGI for say human optimal function, if you will. And the idea in essence is that if you had, say you had an intelligent agent. So right now, when you think about your phone, right, your phone, much of the AI is built by third parties that have their own motivations, right? The motivation for you to click on things, for you to buy things. So imagine that you had an agent that was about optimizing you, right? Like your health, your mental health, your education, all that. And that could happen, but it's a different business structure, right? That needs to happen. So my belief is that so right now there's a lot of things preventing people from fully engaging with in the real world with families and socially, and that's leading to a lot of the problems that you mentioned. I think that actually the AGI agents that we're talking about, especially if you look at Korsivsky's work that looks at how should people, what's an optimal functioning of these kind of generally intelligent time-binding agents, how should those work? I mean, frankly, if you're just aware that your role as a human being is to be a time binder to kind of help the next generation move forward more, just keeping that in mind solves a lot of problems. And of course, your family, yeah.
Of course, my role is to help my people right next to me. It's my family, right? My community, my neighbors, and
Yourself.
that hypothetical agent on another side of the phone will somehow arrange it for me and even guide me to do that. It sounds
It would
scary.
be easy. It would be very easy.
Oh my
right?
God, it sounds scary. It's terrifying.
No,
I
no,
think.
no, it has to be. I mean, there's obviously a lot of privacy and other concerns about that, but I think, you know, and I understand that there's a lot of skepticism because technology so far has not exactly been that helpful, right? So you have to be very careful about how this is done.
Absolutely. And behind the
Everything is a
technology,
double-edged
there are
sword.
people.
Yeah.
Behind the technology, there are people. And there are real people who create algorithms. And those real people belong in one or the other political affiliation party. And those people programmed how I have to behave and how my children have to behave.
Unless your agent was built by another AI, which is also scary. That's the whole
Absolutely, absolutely, yes. So it's some kind of entity that will control my, I don't know, life. And you do not even know my affiliation yet.
Well, I think the first step, you know, what we talked about today, the first step for people is to say, is to learn something about, you know, okay, so I'm a time binder. What does that mean? Okay, so I have abstraction, and maybe to learn, as Korsivsky suggested, how does your abstracting mechanism work? How does it go wrong? And just kind of ensure that you work optimally in that sense. You know, if you get that first step done personally, and that's personal work. There's no agent to do that, but maybe we can, you know, create apps or something to help you do that. But you know, if people were to just you know, use the structural differential, understand, you know, I think it could be helpful.
From scientific point of view, it's very interesting. I had a very good time just learning about this. From the practical point of view, like a self-help, and you're talking that people need that help. I feel like, okay, before reading all those books and learning from all those charts and decoding the terminology, people cannot understand what it was about.
And that's why it hasn't happened.
Yes, but
have you heard? How many people know Korsivsky or general semantics?
Not many.
Nobody.
Have you heard about? It's much more plain language. Have you heard about Eckhart Tolle? He's a German writer, and he's Here and Now. I see a lot of similarities about symbols, about creating bond and time binding. He used different terminology, but the same thing. And about self-help and about abstract yourself from all the unnecessary information, concentrate on what you are right now and who is next to you. Just close.
I've seen a lot of his work, actually. I like his work. Very interesting. Yeah, that's a good.
Yeah, I really like his.
And the key problem is that nobody's going to, you know, if you are not properly aware of your abstracting process, will you read a 1,000-page book about it? I don't think
Absolutely.
so. It's not going to happen.
Any other questions for Hugo? We got about 5 minutes, I guess, left.
Oh, just a off the wall comment. 99.9% of the things we call AI right now and have been developed under that title are really nothing more than machine learning pattern recognition.
Absolutely.
Yes.
We're not even anywhere close to AI, real AI.
Well, ML and machine learning, deep learning is not, but as you know, it's a big planet, 10 billion people or so. Some of us are doing something a little bit different that's a little bit closer to what people would think of AI, but I think it's part of the hype, right? There's a lot of motivation to say, hey, look at my fantastic new AI, and it's really just machine learning, the statistics. But at the same time, when you look at, like DALL-E 2 or image gen, right? The large language models with that generate art, through the fusion process or other algorithms, the results are pretty amazing, right? That you could tell a system, hey, draw me a purple elephant flying to the moon or whatever, and it does it. And it's something that kind of makes sort of sense. But no, I totally agree. It's just pattern recognition for the most part.
The one thing that puzzles me is how do you get to the right abstraction? I think you said that's something that you have to work out for yourself. But
how do you get to the right abstraction for
it seems like that's what Gorgipsky's basic argument is that the abstractions that we make are typically not very good ones. So in order to improve, we need to kind of there's therapy to get to good abstractions.
In a word, the first major step is to realize that all abstractions are wrong, that they're just what an abstraction is, and that it's not reality, that there's a big difference. And so he starts out with little kids by saying, here's what an apple is, and he goes through all the things. And then, they learn firsthand that there's a big difference between this abstraction of what an apple is and an actual apple that you bite into, right? So he has a bunch of mechanisms to kind of just formalize that one small basic thing. It's a big deal. I mean, conceptually, we all know, yeah, of course I know that, saying the word apple and my concepts of apple are not an apple. We all know that it's trivial, it's obvious. But neurologically, though, when you talk about some stressful things, you actually are having physiological responses, and so he goes through a process of how you begin to realize that the whole world, and that's why he uses kind of quantum mechanical, atomic level things to realize that nothing that you see is what you think it is, right? I mean, the actual world is very, very different than what the objects that you feel that you have. But it's a little bit of a slog. I mean, maybe there's another, if you want, we can another session more focused on that, right? How do you go through the process? I had a lot of friends that did this, and they were all like, it lasts for about 5 years, and then they said, okay, when they start getting stressed out again, they say, okay, I need to spend like another week with the structural differential.
It sounds like it would help a lot.
It does. Yeah, a lot of people that
I can see how it's kind of universally applicable to man and machine.
May I ask you, in our childhood, when we read fairy tales and watched some fantastic movies, and we were so much into it, and it was absolute abstraction, but somehow in the back of our mind, we differentiated it. We combined the abstraction and fantasy with the reality. And we didn't need to be taught what is the reality, the apple on the screen and apple in the reality. It's different apples. It was going naturally. And I'm coming back to my statement that time binding between generations is totally broken. And it was so good, but now it's broken, and all this scientific terminology trying to somehow substitute what existed before sounds a little bit, I'm skeptical about that.
Well, I would disagree that time binding between generations is broken. As an example, look at the number of books that are written, the number of journal articles, and the number of journals that are out there. Yes. From generation to generation, we learn one hell of a lot.
But do young people read right now?
Yes.
Can they read? No. I mean, we're seeing.
Yes, they do.
Problems,
oh
right?
my
Yes,
God.
Yeah.
I hope you are right, because I do not see people reading books. They
it's
read
more,
news.
It's more, because attention is very difficult, right? With YouTube and social media, it's just like very gratifying to just quickly, see what's happening. Actually, there's studies showing that the neurochemicals that are generated by children or adults that work with social media on your phone are as addictive or more addictive than many drugs, right? So it's
yes, I agree. I thought I am immune from that, but I started noticing even in myself, and I'm not that young, that if I watch or read something long, I want either fast forward or I want to read the conclusion, and then I just physically stop myself because it's.
So we've gone way over, by the way. Mike, are
Huh?
you sorry about? I think Mike wants to kick us out now because we're going too long, right, Mike?
Oh,
Too
no,
much.
no,
Sorry.
I'm not gonna kick anybody out. We are just about out of time there. Actually, we're out of time,
Okay.
given the schedule, but so Hugo, thanks a lot. I think this, I like time. It seems like a really good overall theory that kind of encompasses everything that's wrong with AI and where it could go. And so thanks a lot. And I'll post the materials pretty soon.
Fantastic. Thank you. Thanks, everyone. And maybe, we'll have more open source and links and things. And maybe there's a way that we can, if you're interested, we can collaborate. But it was a fascinating discussion, everything from the philosophical to, some other things. It was fascinating. Thank you very much. Take care.
Thank you
Everyone.
very
Bye,
much. It was
everybody.
very
Thanks.
nice meeting everybody.
Thank you. Bye.
Bye-bye.